Welcome to EPG Pathshala. My name is Vidya-mitra Vasanta. I am on the teaching faculty of the Department of Linguistics at Osmania University, Hyderabad. My lecture relates to course 10, course number 10, module 24 of Neurolinguistics. The topic is apraxia. In this lecture, I will explain the concept of apraxia, mention different types of apraxias, discuss typical characteristics of apraxia of speech, and then share a couple of speech and writing samples of apraxic patients in relation to Hindi and Kannada. Apraxia is a Greek word. It means no action or inability to perform action. Apraxic patients can move their speech organs or even limbs or whatever. Action is both verbal and non-verbal. So, they can move their speech organs or other parts of their body on their own. But when you ask them to do, they can't do it. So, if you say pout your lips, they can't pout. If you say make a fist, they can't do it. But when you don't ask, by themselves they can do this. In other words, the point to be noted is the dissociation between automatic versus volitional movements is the hallmark of apraxia. So, that is the main definition. When there is a dissociation between doing things automatically versus doing things willfully. Let's look at some typical responses quoted in the literature by neurologists, neurophysicians of apraxic patients. The examiner says, pretend you are hammering a nail. You will have no problem doing that, right? You can pretend that. I'm going to quote some typical responses of apraxic patients, neurophysicians shared. Examiner says, pretend you are hammering a nail. Okay. The patient makes a fist and bangs it on the table instead of holding a pretend handle as you or I might do that. Examiner says, pretend you are combing your hair. Okay. The patient might stroke his hair with his palm or wriggle his fingers in the hair instead of holding and moving an imaginary comb. The examiner says, pretend waving a goodbye to someone. The patient might stare at his hand intently, trying to figure out what to do or flail it around near your face. Examiner says, what does waving a goodbye mean? Patient will say, that is what you do when somebody is parting company. Notice, patient clearly understands at the conceptual level what is expected, alright, but unable to conjure up a dynamic internal picture of the required action that can guide the muscles to mime that action. So, he knows that waving a goodbye means that's what you do when somebody is leaving. He knows that. But what he could not do is action. So, this is apraxia. What is the neural basis for apraxia? It is neurons in the primary motor cortex, supplementary motor cortex and premotor cortex that give rise to that huge corticospinal tract which connects brain with the spinal tract. It is one of the direct descending pathways that connect the brain to the motor neurons in the spinal cord, and the tract comes through brainstem. It is the integrity of this tract that ensures voluntary movement of our body. Whether you want to raise your hand or whatever voluntary movement with your legs, hands, shoulders, whatever movement you want to do, this tract has to be intact, and only then you can do voluntary movement. In order to understand which of the brain areas are involved, we need to study the figure displayed on the screen. Notice the premotor cortex close to Broca's area in the frontal lobe and supplementary motor cortex also in the superior part of the frontal lobe, and primary motor area which is right next to supplementary motor area in the frontal lobe, plus the posterior parietal lobe. These are the areas which control all voluntary motor movements that we are involved in. I've said that apraxia can be non-speech or speech. Non-speech apraxias, some types are ideational apraxia, impairment in the concept of action or in the sequential use of multiple objects. Okay. Suppose I lay out certain things which are required to make tea and serve tea to someone. There is a procedure we follow in serving tea. Apraxic patients with ideational apraxia are unable to follow the procedure. Right? Ideomotor apraxia, impairment in the use of skilled voluntary movements on command. Spatial and temporal errors in executing the movements. The way they move in the space or the slowness or the fastness with which they move can be impaired in ideomotor apraxia. Limb kinetic apraxia, again slowness or stiffness in the movement with loss of precise movement, that is limb kinetic apraxia. These three major types of non-speech apraxias have a damage confined to certain parts of the brain, and please see the figure on the screen and correspond. If you see 1, it means it's ideational apraxia, 2 corresponds to ideomotor apraxia, 3 corresponds to limb kinetic apraxia, and all of them are the location is in the parietal lobe. 1, 2, 3. Okay, you study the figure in relation to the description to understand more. But what we are interested in today's lecture is more about apraxia of speech, not non-speech apraxia. So let's it's abbreviated as AOS, apraxia of speech. So I might once in a while say AOS, basically is apraxia of speech. It characterizes deficits affecting sequencing and timing aspects of speech involving motor planning component in speech production system. It affects one's capacity to select, program or execute appropriate positioning of speech musculature for volitional production of speech. It can manifest as what is called neurogenic stuttering, characterized by repetition of sounds and syllables. Here is a sample of neurogenic stuttering exhibited by a Hindi-speaking patient. You see on the screen the sample of writing. Mohammed Rafiq, name changed. He is a 65-year-old male diagnosed with Broca's aphasia, and he spoke the way he did with lots of repetition of syllables. Please study the sample that is displayed on the screen to understand how neurogenic stuttering is characterized. But let's spend another minute or two on apraxia of speech. In this condition, lexical processing and phonological assembly are relatively intact. In other words, apraxia of speech patients' problem is not about selecting the appropriate word or even thinking about what goes into that word, but the difficulty is confined to translation of those phonological representations into articulatory commands. You have learnt about representations, so they'll access those representations, but they're not able to translate them into motor commands which have to be executed by the muscles of speech. Some of the phonemic paraphasias associated with apraxia of speech resemble those exhibited by aphasic patients, conduction aphasia. Although there is a difference between conduction aphasia and apraxia of speech. In conduction aphasia, there are problems with selection of appropriate phonemes, whereas in apraxia of speech, the problem is with motor programming of correctly selected phonemes. Apraxia of speech, the problem is not selecting phonemes, but with motor programming of selected phonemes. How does one test for presence of apraxia of speech? Let me share one battery designed by some scientists for checking whether aphasic patients have apraxia of speech. You ask the patient to repeat some sounds. You tell them Repeat after me. I will say ka, ga, ta, whatever, you repeat after me. About 5 to 18 items like that. Then repeat the following words after me, about 10-15 items. Repeat these word sequences. So you say cat, catnip, catapult, catastrophe quickly. So cat is small, catnip has cat in it, catapult has catapult is again consists of cat, catastrophe has cat, but the syllable length is increasing. How they are able to repeat that word is what you have to check. Repeat each word 3 times. Repeat these sentences. Repeat each syllable as fast as you can. Count numbers 1 to 10. Say the days of the week. Sing popular rhymes like Jingle Bells. Conversational and narrative speech. Reading. So these are some of the items in test batteries designed for English speaking apraxia of speech patients. So based on such batteries, they have said that these are the major speech characteristics the patients present. Groping for articulation. So you've seen earlier, tr, 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 like that. They grope towards the pain word. Slow rate of speech. Halting, effortful phoneme sequences. Articulation errors. Inconsistent articulation or on repeated productions. Prolonged duration of vowels. Automatic speech is much better than propositional speech. Aware of one's own errors and dysprosody. What then is the theoretical basis for apraxia? According to traditional models of speech production, aphasia is more central disorder affecting integration of information that is reaching the brain. As opposed to this, dysarthria is considered as lower level neuromuscular incoordination, and apraxia falls somewhere in the middle. So apraxia is considered as it's a disorder of programming of articulators involved in speech production. So you have aphasia on top, dysarthria at the bottom, and apraxia in the middle, as shown in the diagram. But more recently, researchers have realized the necessity of introducing speech motor component that translates abstract symbolic representations into movement gestures. What are abstract symbolic representations? There are phonemes, features underlying phonemes, there are phonemes, phonemes become syllables, syllable becomes words. These are abstract symbolic representations. But what about Broca's aphasia? When Broca's area sends signals to the motor cortex to give commands to the speech muscles to move. So that aspect of speech motor control has to be incorporated into any model of speech production. And to account for the relation between intention of doing something, which is not impaired in apraxia, and actually doing the action, which is impaired in apraxia. So you have to, models of apraxia must be able to deal with how come this patient knows what is waving a goodbye means, but not able to wave. What is this discrepancy? That is what researchers are trying to figure out. So what are some of the new insights about apraxia? In some apraxia, tool use is affected, but gesture recognition and imitation are spared. So if you ask them hammer a nail, they may not be able to do that action, but they will be able to match two gestures which are showing hammering. They say this and this matches. So they are able to recognize the gestures. Or it can be the other way also. Reverse happens in some other kinds of apraxia. So because of all this, in recent times there is a talk of what is known as, we probably have an action lexicon. The traditional models talk about lexicon containing information about meanings, syntactic, semantic level meanings, which are lemmas, and then you have the word forms, right? So lexemes, lemmas and lexemes is the main division that is talked of in regular idea of architecture of a lexicon. But now, because of studies based on apraxias, now researchers are saying perhaps we also need to think about action lexicon. So in more recently developed models, more attention is given to the notion of syllable rather than a phoneme. Earlier people were paying attention to phonemes, consonants, vowels, but now they are paying attention to syllables because they are saying Probably apraxia of speech, what is affected is mental syllabary. Damage to some kind of disruption to mental syllabary causes apraxia of speech. Let's look at a case study. There is agraphia is also associated with apraxia. This information is given in the e-text about a 67-year-old Kannada-speaking patient with master's level education who presented with lesions in the frontal and parietal lobes. Go back and read the e-text for details about this patient, but look at this writing sample here on the screen. Look at the sample. This is a patient, I think economics professor or something like that. Look at the way he's written Kannada, look at the way he's written English, look at the way he failed to copy the clock, the face of the clock. The small one on top is the patient's drawing of the clock. Stare at this picture and read more about apraxia and see how writing is affected in this particular apraxic patient. To summarize my lecture today, we looked at definition of apraxia, how apraxia results in loss of voluntary action, and then there are some non-verbal apraxias, and the neural basis of those non-verbal apraxias also we looked at. Then the focus was more on apraxia of speech, and I have presented speech characteristics of apraxia of speech in relation to English, and then gave one or two samples of how writing gets affected in apraxia of speech in a Hindi speaking patient. If you have any doubts, consult the e-text. Thank you.